Hi friends, I am Dr. Santaji Pawar, working as an assistant professor, SVERI's College of Engineering, Pandharpur. So today we discuss on scalars and vectors. In the last lecture already we had discussed about the physical quantities. The physical quantities are measured directly or indirectly. Also, these physical quantities are expressed all the laws of physics. These all physical quantities are again classified in two categories. So first one is the scalar physical quantities and the second one is the vector physical quantities. If we discuss about the scalar physical quantities, then these scalar physical quantities having only magnitude. So example of scalar quantities: length, time, velocities. These are the some of the examples of the scalar quantities. Means these scalar quantities having only magnitude. We can say these quantities are known as the scalar quantity. Okay, on the other side, if we discuss about the vectors or the vector physical quantities, these vectors having both magnitude and directions. Okay, if we take examples of vector quantities: displacement, velocity, force, these are the some of the examples of the vectors. Means displacement, velocity, force having magnitude and directions. So we can say these quantities are known as the vectors. Okay, again if we go to the describe scalar quantities, then we require the some terms. If we go to the describe vector quantities, then we require some terms. So first we discuss about the scalar quantities. If we go to the describe a scalar quantities, then we require first the specific unit of that quantity. Second, that scalar quantity, the number of units that unit is contained in that quantity. मीन्स जेव्हा आपण स्केलर क्वांटिटी डिस्क्राइब करायला जातो तेव्हा त्याच्यासाठी दोन टर्म महत्त्वाचे आहेत, त्या पाहिजेत आपल्याला, तेव्हाच आपण ती स्केलर क्वांटिटी डिस्क्राइब करू शकतो. त्याच्यातली पहिली टर्म आहे द स्पेसिफिक युनिट ऑफ दॅट क्वांटिटी. त्या क्वांटिटीचं स्पेसिफिक युनिट पाहिजे. आणि द सेकंड दुसरी टर्म आहे द नंबर ऑफ टाइम्स दॅट युनिट इज कंटेन्ड इन दॅट क्वांटिटी. Okay, if we take an example of scalar quantity, a bag contains 100 kilogram of sugar. This is the example. Here in that example, kilogram is the unit and 100 is the number of unit of sugar present in the bag. Okay, so this is the scalar quantity. Okay, when we go to the describe a vector quantity, then we require specific unit of that quantity, the number of times that unit is contained in that quantity, and the orientation of that quantity. जेव्हा आपण वेक्टर क्वांटिटी डिस्क्राइब करायला जात असतो त्यावेळेस आपल्याला या तीन टर्म पाहिजेत. सो कोणत्या आहेत त्या तीन टर्म? फर्स्ट, स्पेसिफिक युनिट ऑफ दॅट क्वांटिटी. आपल्याला त्या क्वांटिटीचं स्पेसिफिक युनिट माहिती पाहिजे. त्याच्यामध्ये नंबर ऑफ टाइम्स दॅट युनिट इज कंटेन्ड इन दॅट क्वांटिटी. अँड द थर्ड वन इज द ओरिएंटेशन ऑफ दॅट क्वांटिटी. Orientation of that quantity is very most important. If we take an example, then a plane is flying from west to east. In that example, with a velocity of 15 meter per second. I repeat, a plane is flying from west to east with a velocity of 50 meter per second. Then in that example, meter per second is the unit of that quantity. 50 is the number of unit of velocity, and west to east is the direction. So this example shows here there is the vector quantity. Again, there are some of the different types of the vector quantities. Now we discuss only vectors. आता आपण इथून पुढे फक्त वेक्टर्स डिस्कस करणार आहे. So there are some of the different types of the vectors. So the first type of vectors is polar vector. Polar vector कशाला म्हणायचं? Polar vector मध्ये काय असतं? The vectors whose direction does not change even through the coordinate system in which it is defined changes is called polar vector. I repeat, vector whose direction does not change even through the coordinate system in which it is defined changes is called polar vector. Examples of the polar vector is force, momentum and acceleration. These are the examples of the polar vector. Again, second type of vector is axial vector. The vector whose direction changes with a coordinate system in which it is defined changes is called axial vector. Second type of vector is axial vector. In that axial vector, the vector whose direction changes with the coordinate system, then we can say yes, there is the axial vector. And the examples of the axial vectors is the angular velocity, torque and the angular momentum. These are the some of the examples of the axial vector. Next type of the vectors is the like vector or parallel vector. Two or more vectors representing same physical quantity are called like vectors if they are parallel to each other. However, their magnitude may be different. जर का आपल्याकडे दोन किंवा दोन पेक्षा जास्त वेक्टर्स असतील तर त्यांना आपण लाईक वेक्टर्स किंवा पॅरलल वेक्टर्स म्हणू शकतो. कधी? जेव्हा ते दोन्ही एकमेकांना पॅरलल असतील तर. However, their magnitude may be different. त्यांची magnitude different असली तरी सुद्धा. But these two vectors representing same physical quantities. See in this figure, A bar and B bar. These are the two like or parallel vectors. Okay. Next type of vector is the unlike vector or anti-parallel vector. What is anti-parallel vector? Two vectors representing same physical quantity are called anti-parallel vector if they act in opposite direction. However, their magnitude may be different. If two vectors representing same physical quantity are known as anti-parallel vector when these two vectors are opposite in direction. However, their magnitude may be different. See here. This is the best example of the anti-parallel vector or the unlike vector. Again, here some of the types of the vectors. Equal vector. So what is meant by equal vector, or what is equal vector? Two or more vectors representing same physical quantity are called equal if their magnitude and directions are same. Here, very important sentence. If their magnitudes and directions are same, then we can say yes, there is equal vector. So next type is the negative vector. A vector having the same magnitude and opposite in direction to that of a given vector is called negative vector. Here very important, same magnitude and opposite in direction to that of a given vector is called a negative vector. Here a bar and b bar are the two vectors. These two vectors are opposite in direction. Then in negative vector we can represent a bar is equal to minus b bar. This is the best example of the negative vector. What is meant by the collinear vector? Sorry, co-initial vector. A vector having the same initial point are called co-initial vectors. Okay, see here there is the four different types of the vector: a bar, b bar, c bar and d bar. These are the four different vectors. But the initial point of all these four vectors is the same point. Here initial point of all the four vectors is the same point. Then we can say these four vectors are the co-initial vectors. The next type of vectors is the collinear vector. Two or more vectors are said to be collinear when they act along the same line. However, their magnitude may be different. Okay, we have two vectors or more than two vectors, and these two vectors or more than two vectors act along the same line. However, their magnitude may be different. But these two or more vectors on the same line, then we can say this vector is a collinear vector. And the last type of vector is the unit vector. A vector whose magnitude equals 1 and used to specify a convenient direction is called a unit vector. In a unit vector, very important is a vector whose magnitude equals to 1. युनिट वेक्टरची मॅग्निट्यूड ही जर का 1 च्या बरोबर असेल तरच आपण त्या वेक्टरला म्हणणार युनिट वेक्टर. ओके, सो नेक्स्ट we discuss about the addition of the vectors. How we add the two or more different vectors. Using the two methods we can add the two or different vectors. First one, when two vectors are acting in the same direction. And the second one is the when two vectors acting at some angle. Okay, see here in that figure, a bar and b bar, these are the two different vectors. Okay, then c bar is equal to a bar plus b bar. This is the first type, or there is the addition of the two vectors. On the other way, cx is equal to ax plus bx. We can add two vectors in different manner. Cy is equal to ay plus by. Again there is the addition of the two vectors. Again this addition of vectors, again there is the different laws of addition or vector addition. So in which the first law is the parallelogram law of vector addition. आता हा parallelogram law of vector addition कधी म्हणणार, कधी असणार, त्या लॉ मध्ये काय असणार आहे, if two vectors acting simultaneously at a point can be represented both in magnitude and direction by the adjacent sides of a parallelogram drawn from a point, then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram passing through that point. And this is the parallelogram law of vector addition. See here in that figure there is the one parallelogram, one side q, other side p, diagonal r. If we calculate or if we go to the find out r, then using the formula r is equal to under root p square plus 2pq cos theta plus q square. or the direction of resultant tan phi is equal to q sin theta divided by p plus q cos theta, or phi is equal to tan inverse into q sin theta divided by p plus q cos theta. This is the first law of vector addition, that is the parallelogram law. And the second law of vector addition is triangle law. This is the second law for the vector addition. What is the triangle law of vector addition? If two vectors acting simultaneously on a body are represented both in magnitude and direction by two sides of a triangle taken in an order, then the resultant both magnitude and direction of these vectors is given by third side of that triangle taken in opposite order. See the figure. In that figure, one side is P and other side is Q, and the angle between this P and Q is phi, and the resultant vector R. Using the formula R is equal to under root P square plus 2PQ cos theta plus Q square, we can find out the value of R. Okay, these are the two most important laws of vector addition. Now we can see some of the examples of the vector addition. Okay, take a first example. If two forces whose magnitudes are in the ratio 3:5 give a resultant of 28 Newton force, if the angle of their inclination is 60 degree, see here there is one correction, 60 degree, then magnitude of each force is, what is the question? See, read, be carefully. Two forces whose magnitudes are in the ratio 3:5 give a resultant of 28 Newton force. Then if angle of their inclination is 60 degree, then magnitude of each force is 10 Newton, 20 Newton, 30 Newton or 50 Newton. ओके, काय सांगितलेलं आहे तुम्हाला क्वेश्चन मध्ये? दोन फोर्सेस दिलेले आहेत आणि त्यांच्या मॅग्निट्यूडचा रेशो आहे 3:5 आणि त्यांचा जो रिझल्टंट फोर्स आहे तो 28 न्यूटन आलेला आहे, आणि ते जे दोन वेक्टर्स दिलेले आहेत त्यांच्यामधला जो इन्क्लिनेशन अँगल आहे तो आहे 60 डिग्री. तर मग प्रत्येक मॅग्निट्यूड वरती फोर्स किती असेल किंवा मॅग्निट्यूड फोर्स वरती मॅग्निट्यूड किती असेल? If we go to the answer, then let's consider A and B be the two forces. See here, two forces म्हटलं आहे, आपण इथे कन्सिडर केलं. Let A and B are the two forces. Okay, as per the ratio 3:5, then A is equal to 3x and B is equal to 5x as per the ratio, and your resultant force R is equal to 28 Newton, and as per the given angle theta is equal to 60 degree. If we divide A by B, then A divided by B is equal to 3 divided by 5. We know the formula for resultant. R is equal to under root A square plus B square plus 2AB cos theta. If we put the given values in that formula, then what we get? We get 28 is equal to under root 3x square plus 5x square plus 2 into 3x into 5x cos 60. Again, if we solve this step, then what we get? We get under root 9x square plus 25x square plus 15x square is equal to 7x. So x is equal to 28 divided by 7 is equal to 4. Hence forces are A is equal to 3 into 4 is equal to 12 Newton. म्हणजे पहिल्या फोर्स वरती तुमची मॅग्निट्यूड किती असेल 12 न्यूटन एवढी असेल आणि दुसऱ्या फोर्स वरती तुमची मॅग्निट्यूड किती असेल B इज इक्वल टू 5 into 4 इज इक्वल टू 20 न्यूटन. So your answer is 20 Newton. Okay, we take another one example based on the parallelogram law or the triangle law. See in that example, two forces of 3 Newton and 4 Newton. इथे दोन फोर्सेस दिलेत, पहिला आहे 3 न्यूटन आणि दुसरा आहे 4 न्यूटन are acting at a point such that the angle between them is 60 degree. Then find the resultant force. या प्रॉब्लेम मध्ये आपल्याला गिवन व्हॅल्यूज कोणते कोणते दिलेले आहेत? दोन फोर्सेस दिलेले आहेत. पहिला फोर्स आहे 3 न्यूटन आणि दुसरा फोर्स आहे 4 न्यूटन. ओके, आणि त्यांच्यामध्ये त्या दोन फोर्सेस मध्ये काहीतरी अँगल आहे आणि तो अँगल आहे 60 डिग्री आहे. आणि आपल्याला विचारलेलं काय आहे, तर रिझल्टंट फोर्स किती असेल, R इज इक्वल टू किती असेल त्याच्यामध्ये. सी as per the example we can draw figure. In that figure, first force in that direction 3 Newton, second force 4 Newton. In between these two forces there is the 60 degree and we can find the value of R. आपल्याला काय फाइंड आउट करायचं आहे, व्हॅल्यू ऑफ R. R जर फाइंड आउट करायचं असेल तर आपल्याला ऍज पर द गिवन फॉर्म्युला गेलं पाहिजे. Then magnitude R of the resultant force is R is equal to under root 3 square plus 4 square plus 2 into 3 into 4 cos 60 degree. If we solve this, then what we get? We get under root 9 plus 16 plus 12 is equal to under root 37 is equal to 6.08 Newton. 6.08 Newton. Then direction of R is given by finding the angle Q. Then tan Q is equal to 3 sin 60 divided by 4 plus 3 cos 60. If we solve this, then what we get? We get 0.472. So value of Q is equal to tan inverse 0.472. Again, if we solve this, then Q is equal to 25.3 degree. Thus, R is 6.08 Newton in magnitude and is at an angle of 25.3 degree to the 4 Newton force. या प्रकारे तुम्हाला सॅम्पल क्वेश्चन्स आहेत. याच्याप्रमाणे तुम्हाला सीईटी मध्ये किंवा जेईई मध्ये सिंपल क्वेश्चन्स विचारले जाऊ शकते. फक्त आपण काय लक्षात ठेवायचंय, आपल्याला गिवन व्हॅल्यू कोणते दिलेले आहेत न्यूमेरिकल मध्ये, त्या गिवन व्हॅल्यू प्रमाणे जर का आपण फिगर ड्रॉ केली आणि त्याच्यानुसार जर ऍज पर द फॉर्म्युला मध्ये जर व्हॅल्यू पुट अप केला तर आन्सर इझिली फाइंड आउट करू शकतो. वी टेक अनदर वन एक्झाम्पल. Okay, in that example, find the x and y components of a 25 meter displacement at an angle of 210 degree. What is the problem? What is the example? Find the x and y components. X आणि y component आपल्याला फाइंड करायचे. त्याच्यासाठी त्यांनी गिवन व्हॅल्यू काय दिले आहे, 25 मीटर डिस्प्लेसमेंट. 25 मीटरची डिस्प्लेसमेंट दिलेली आहे आणि त्याच्यामध्ये अँगल किती दिलेला आहे, त्याच्यामध्ये 210 डिग्रीचा अँगल दिलेला आहे. सो वी ड्रॉ अ फिगर ऍज पर द गिवन एक्झाम्पल. दिस इज द फिगर. सेंटर इनिशियल पॉइंट O. In between the two vectors there is the angle 210 degree. Okay, OA is the displacement vector. The angle with a horizontal axis is 210 degree minus 180 degree is equal to 30 degree. Then x component is equal to OB is equal to minus 25 cos 30 degree is equal to minus 21.7. This is the x component. What is the y component? Y component is equal to AB is equal to minus 25 sine 30 degree is equal to minus 12.5 meter. These are the two components as per the given example. Okay, if we take another example based on the parallelogram law and the triangle law, find the resultant of the following two displacements: 2 meter at 30 degree and 4 meter at 120 degree. Then the angles are taken relative to the x axis. Then find the resultant displacement between the two forces. Okay, so we draw two figures as per the given. Rx is equal to 2 cos 30 degree minus 4 cos 60 degree is equal to minus 0.268 meter. Ry is equal to 2 sin 30 degree plus 4 sin 60 degree is equal to 4.46 meter. Then R is equal to under root Rx square plus Ry square. If we put the above two values in that equation, then what we get? We get is equal to, and R is equal to under root minus 0.268 square plus 4.46 square is equal to 4.47 meter. Then tan Q is equal to Ry divided by Rx is equal to 4.46 divided by 0.268. Then Q is equal to 86.6 degree. So P is equal to 180 degree minus 86.6 degree, and P is equal to 93.4 degree. This is the resultant displacement between the two vectors. Okay, so next we discuss about the polygon law of vector. What is the polygon law of vector? याच्यामध्ये काय असतं? Polygon law आपल्याला काय सांगतोय? Polygon law of vector addition states that if a number of vectors can be represented in magnitude and direction by the sides of a polygon taken in the same order, then their resultant is represented in magnitude and direction by the closing side of the polygon taken in the opposite order. See here in the below figure, A bar, B bar, C bar and D bar. These are the different vectors. And your resultant vector is R bar. Okay, how we find out the vector R bar? Then where your vector R bar is A bar plus B bar plus C bar plus D bar is equal to R bar. This is your resultant vector R bar. Okay, this is your polygon law of vector. Okay, we take one example on polygon law of vector. Suppose A, B, C, D, E, F is a regular hexagon. What is A, B, C, D, E, F is a regular hexagon. Then what is the value of a vector AB plus BC, AC plus AD plus AE plus AF? If we go to the answer, then AB plus AC plus AD plus AE plus AF is equal to AB plus AC plus AF plus AD plus AE is equal to AB plus AC plus CD plus AD plus AE. is equal to AB plus AD plus AD plus 2AE. Here addition of 2AD means 2AD plus AB plus AE. Again is equal to 2AD plus ED plus AE is equal to 2AD plus AD is equal to 3AD. Means 3AD into 2OE. Since O is the center and AO is equal to OD, so is equal to 6AO. So what is the value of a vector AB plus AC plus AD plus AE plus AF is equal to 6AO. This is the example on a hexagon. Okay, so next is the subtraction of vectors. आतापर्यंत आपण वेक्टरची ऍडिशन बघितली होती. आता आपण वेक्टरची सबट्रॅक्शन बघणार आहोत. व्हॉट इज द सबट्रॅक्शन ऑफ वेक्टर्स? वेक्टरच्या सबट्रॅक्शन मध्ये काय असतं? The process of subtracting one vector from another vector is equivalent to adding vectorially the negative of the vector to be subtracted. See here, best example, B bar and minus B bar are the two different vectors, and these two vectors are opposite in direction. If we subtract, okay, from this figure, two vectors A bar, B bar and minus B bar. B bar and minus B bar, these two vectors are opposite to each other. Okay, vector subtraction is a special case of vector addition because A minus B is equal to A plus minus B, where negative vector has the same magnitude but opposite in direction of the positive vector. पॉझिटिव्ह वेक्टरच्या अपोजिट डायरेक्शनला असतो, तो निगेटिव्ह साइन इंडिकेट करत असतो. ओके, नेक्स्ट युअर डायरेक्शन कोसाइन्स. व्हाट इज मीन बाय द डायरेक्शन कोसाइन्स? व्हेन अ directed line OP passing through the origin makes alpha, beta and gamma angles. जेव्हा OP लाइन ही एका ओरिजिन मधून पास होते तेव्हा ती लाइन तीन एंगल्स तयार करते. कोणते कोणते एंगल्स? अल्फा, बीटा एंड गॅमा. कुठं? तीन वेगवेगळ्या ऍक्सिस वरती. कोणते कोणते आहेत ते तीन ऍक्सिस? एक्स, वाय एंड झेड ऍक्सिस रिस्पेक्टिव्हली. व्हेन अ डायरेक्टेड लाइन OP passing through a origin makes alpha, beta and gamma angles with the x, y and z axis respectively with O as a reference. These angles are referred as the direction angles with the line, and the cosine of these angles give us the direction cosine. These direction cosine are usually represented as 1, m and n. Represented as 1, m and n. Okay, next is the position vector. What is the position vector? Position vector is used to specify the position of a certain body. What is meant by position vector? Position vector is used to specify the position of a certain body. Knowing the position of a body is vital when comes to describe the motion of that body. The position vector of an object is measured from the origin in general. Okay, here O is the origin and P is the object. So in that case position vector R bar is equal to x I cap plus y j cap plus z k cap, where I cap is unit vector along x axis, j cap is again unit vector along y axis, and k k cap is unit vector along z direction or z direction. This is the position vector. Again, there is the two product, very important, scalar product and the vector product. Again, this first we discuss about the scalar product or scalar product, we can say dot product. दोन इम्पॉर्टंट टर्म आहेत खूप महत्त्वाच्या, पहिली स्केलर प्रोडक्ट आणि दुसरी व्हेक्टर प्रोडक्ट. आपण जेव्हा स्केलर प्रोडक्ट डिस्कस करणार आहोत त्या स्केलर प्रोडक्टलाच आपण डॉट प्रोडक्ट सुद्धा म्हणू शकतो. मग हा डॉट प्रोडक्ट किंवा स्केलर प्रोडक्ट काय आहे, कशाला म्हणायचं? टू व्हेक्टर्स इज डिफाइन्ड ॲज द प्रोडक्ट of their magnitudes and the cosine of angle between the two, or the dot product or the scalar product is the product of the magnitude of one of the vector quantities and the scalar component of second vector in the direction of the first vector, and scalar product are represented as a dot b. That's why we can say dot product a dot b is equal to mod of a into mod of b into cos theta. So this is the formula for the scalar product or the dot product. Okay, so we take an example on the scalar product. What is the example for scalar product? Calculate the dot product of vectors a and b. See in the figure there is the two vectors a bar and b bar. So what is the value of a dot b? दोन वेक्टरचं प्रोडक्ट घ्या, a dot b चा काय येणार? a dot b is equal to mod of a into mod of b into cos theta. थीटाची व्हॅल्यू किती आहे? 59.5 डिग्री. a ची व्हॅल्यू किती आहे? 10. b ची व्हॅल्यू किती आहे? 13. Then go to the solution. a dot b is equal to 10 into 13 into what is the value? Cos 59.5 degree is equal to 0.5075. Again, if we calculate this, a dot b is equal to 65.98. This is the very simple example. Or using the scalar product or dot product, we can find out the value of a dot b. Take another example of dot product. See second figure. A dot b is equal to mod of a into mod of b into cos theta. Okay, here 90 degree angle between the two vectors a vector and b vector, 90 degree. So cos 90 is equal to 0. So your value a dot b is equal to again 0. Okay, we go to the second type, that is the vector product or the cross product. आपण वेक्टर प्रोडक्टलाच क्रॉस प्रोडक्ट सुद्धा म्हणू शकतो. And for that the vector product of two vectors is a vector whose magnitude is equal to the product of magnitudes of the two vectors and sine of the angle between them. In the last case there is the cos theta. In case of vector product or cos product, we can use the sin theta. But in cross product, there is a cross b. See here, very important. In dot product, we use a dot b. In dot product or scalar product, we use a dot b and cos theta. But in case of cross product or vector product, we can use a cross b and sin theta. So formula for the vector product or cross product, a cross b is equal to mod of a into mod of b into sin theta into n. N is the unit vector. N indicates the unit vector. Okay, here synopsis based on the scalars and the vectors. As scalar and vectors, या चॅप्टर मधून आपल्याला जो काही सिनॉप्सिस भेटला इन वन सेंटेन्स, इन शॉर्ट, this synopsis is very important for your CET in one sentence. आपल्याला CET चं प्रिपरेशन करायचं आहे म्हणजे फुल डेरिवेशन किंवा फुल लेंथचा स्टडी करायचा नाही. इन शॉर्ट वन सेंटेन्स मध्ये आपल्याला ते लक्षात राहिलं पाहिजे, ते डिस्क्राइब करायचं, ते सांगायचं आहे आन्सर. जस्ट टिक टू द MCQ. मग जर का MCQ चं आपल्याला प्रिपरेशन करायचं असेल तर त्याच्यासाठी आपल्याला वन सेंटेन्स प्रिपरेशन करणं सगळ्यात महत्त्वाचं आहे. सो हियर सिनॉप्सिस बेस्ड ऑन द स्केलर्स अँड द वेक्टर्स. In that synopsis, just we highlight on that synopsis, physical quantities having only magnitude, then we can say yes, there is the scalars. And the examples of the scalar quantities, scalar चे कोणते कोणते एक्झाम्पल आहे? Distance, speed, area, volume, mass, density, work, power, energy, time, frequency, temperature, electric charge, electric current, potential, resistance, capacitance, velocity of light, and intensity of sound. These are the examples of the scalar quantities having only magnitude. तुम्हाला MCQ मध्ये काहीतरी फिजिकल क्वांटिटीज दिल्या जातील आणि विचारलं जाईल ही स्केलर आहे का वेक्टर आहे. त्यामुळे तुम्हाला हे एक्झाम्पल स्केलरचे तुम्हाला व्यवस्थित बघावे लागतील की ज्यांना फक्त आणि फक्त मॅग्निट्यूड आहे, डायरेक्शन नाहीये. इफ वी गो टू द अदर साइड वेक्टर्स, in that vectors there is the both magnitude as well as direction. वेक्टरला तुम्हाला दोन असते, मॅग्निट्यूड असते आणि डायरेक्शन असते. मग त्याचे एक्झाम्पल कोणते कोणते आपण घेऊ शकतो? डिस्प्लेसमेंट, वेलोसिटी, एक्सेलरेशन, मोमेंटम, फोर्स, इम्पल्स, अँग्युलर डिस्प्लेसमेंट, अँग्युलर वेलोसिटी, अँग्युलर एक्सेलरेशन, मोमेंट ऑफ अ फोर्स, टॉर्क, मॅग्नेटिक मोमेंट, मॅग्नेटिक induction field, intensity of electric field. These are the some of the examples of the vector quantities having both magnitude as well as direction. MCQ मध्ये तुम्हाला विचारलं जाऊ शकेल की खालील पैकी कोणती क्वांटिटी ही वेक्टर क्वांटिटी आहे. मग त्याच्यामध्ये तुम्हाला 3 ह्या स्केलर क्वांटिटी दिल्या जातील आणि एकच कोणती तरी वेक्टरची क्वांटिटी दिली जाईल. तुम्हाला त्याच्यामुळे वेक्टर क्वांटिटी कोणत्या आहेत आणि फिजिकल क्वांटिटी कोणत्या आहेत याचे सगळे एक्झाम्पल माहिती असणं गरजेचं आहे. किंवा आपल्याला माहिती नाही तर ज्या काही ऑप्शन मध्ये क्वांटिटी दिलेल्या आहेत त्यांना मॅग्निट्यूड आणि डायरेक्शन आहे का हे चेक करणं महत्त्वाचं आहे. जर का तुम्हाला ते माहिती झालं तर तुम्ही इझिली MCQ सॉल्व्ह करू शकता. तुम्ही या चॅप्टर वरती जे MCQ आहेत ते MCQ सॉल्व्ह करण्यासाठी तुम्हाला याच्यातले काही फॉर्म्युला माहिती असणं गरजेचं आहे. ओके, अगेन इफ वी गो टू द टाइप्स ऑफ द वेक्टर्स, तुम्हाला एखादं स्टेटमेंट दिलं जाईल आणि त्या स्टेटमेंट मध्ये विचारलं जाईल इज द डॅश डॅश टाइप ऑफ वेक्टर. सपोज तुम्हाला एक एक्झाम्पल दिलं, वेक्टर्स आर इक्वल इफ दे हॅव सेम मॅग्निट्यूड अँड सेम डायरेक्शन. दोन वेक्टर आहेत ते इक्वल आहेत, त्यांचे डायरेक्शन आणि मॅग्निट्यूड ही सेम आहे, तर मग तो तुमचा कोणता वेक्टर आहे? तुमचा असेल आन्सर इक्वल वेक्टर. तुम्हाला युनिट वेक्टरचे एक्झाम्पल विचारलं जाईल, की तुम्हाला पोलर वेक्टर विचारलं जाईल, एक्सियल वेक्टर विचारलं जाईल, लिनियर कोलिनियर वेक्टर विचारलं जाईल, को इनिशियल वेक्टर विचारलं जाईल. त्यांचे स्टेटमेंट दिलं जाईल आणि हा कोणता वेक्टर आहे हे तुम्हाला सांगायला लागेल, हा कोणत्या टाइपचा वेक्टर आहे. त्यामुळे तुम्हाला जे डिफरंट टाइपचे वेक्टर्स आहेत त्यांचे स्टेटमेंट माहिती असणं गरजेचं आहे. ओके, इफ P bar and Q bar are two vectors and their resultant vector is given by R bar. मग तुम्हाला दोन P bar आणि Q bar हे दोन वेक्टर दिलेले आहेत आणि त्यांचा रिझल्टंट वेक्टर जर R bar फाइंड आउट करायचा असेल तर तुम्ही कसं करणार? P bar plus Q bar is equal to R bar. ओके, अगेन This is the synopsis based on the scalars and the vectors. Important formulas दिलेला आहे. Resultant of two vectors always lies in the plane containing the vectors closer to vectors of larger magnitude. जेव्हा तुम्ही वेक्टर ऍडिशन फॉलोज करता तेव्हा तुम्हाला वेगवेगळे लॉज येतात. कम्युटेटिव्ह लॉ p बार प्लस q बार इज इक्वल टू q बार प्लस p बार. असोसिएटिव्ह लॉ p बार प्लस इन ब्रॅकेट q बार प्लस r बार इज इक्वल टू p बार प्लस q बार ब्रॅकेटच्या बाहेर प्लस r बार. डिस्ट्रीब्युटिव्ह लॉ k इंटू p बार प्लस q बार इज इक्वल टू डिस्ट्रीब्यूट करा k p बार प्लस k q बार. Here k is a scalar when जेव्हा तुमचा k हा स्केलर क्वांटिटी असेल. ओके इफ वी गो टू द वेक्टर सबट्रॅक्शन त्याच्यामध्ये काहीतरी टर्म्स असतील. डज नॉट ओबे कम्युटेटिव्ह लॉ. सबट्रॅक्शन मध्ये कम्युटेटिव्ह लॉ ओबे केला जात नाही. मीन्स p बार मायनस q बार इज नॉट इक्वल टू द q बार मायनस p बार. अगेन इन वेक्टर सबट्रॅक्शन your associative law does not obey associative law. Means p bar minus in bracket q bar minus r bar is not equal to p bar minus q bar minus r bar. But in case of vector subtraction, your distributive law obeys. K into in bracket p bar minus q bar is equal to k p bar minus k q bar. So again this synopsis is very important in one sentence for your just MCQ or your CET. Again here some of the important terms in one sentence, very important for your CET. Again this slide is also important in one sentence. And last again this slide is very important in one sentence. Your MCQ, your formulae based on the scalars and the vectors. This is the synopsis based on the scalars and the vectors. Examples of the cross product. Angular moment L bar is equal to R bar into P bar. Torque tau bar is equal to R bar into F bar. Or force on a charge F bar is equal to Q into V bar into B bar. So this synopsis is very important. Just in last 3 or 4 slides you can study whole scalar and vector chapter. या लास्टच्या 3 ते 4 स्लाइड मध्ये जो सिनॉप्सिस दिलेला आहे त्याच्यावरून तुम्हाला सीईटी साठी ज्या नोट्स जे पॉइंट्स ज्या फॉर्म्युले तुम्हाला वन सेंटेन्स मध्ये पाहिजे होते त्या तुम्हाला इथे भेटून जातील. सो ॲट द एंड थँक यू. सो टुडे वी स्टॉप हियर. थँक यू.